Hello and welcome everyone to today's webinar by the AM Academy. Today I want to talk about combining the Shining3D EinScan H with the Raise3D printers with PPprint's polypropylene filament and why this is a good idea. So let's get right into it. The first step that we have in this combination is the Shining3D EinScan H scanner. This is a hybrid scanner, which means that it has two different ways of picking up an object. First up, let's see what's actually in the box. I'm going to open this up. And then we can see first up, we have a calibration plate along with a calibration guide that you will need in order to properly calibrate. So in order to calibrate the scanner, you need to place this on the table and then put the calibration board on top of it at an angle. That's what the guide is for. After calibrating your scanner, always put the calibration board into a safe spot. You do not want to damage this because the calibration boards are linked to a specific scanner with the serial number. You really don't want to damage this because otherwise your calibration quality and accuracy will just go down the drain. So keep it safe. Next up, of course, we have the scanning unit itself. This is what it looks like. It has a couple of controls on the back, two plugs at the bottom, and of course all the optical units on the front. Then there is a power brick along with different adapters depending on what country you are in. In our case, that is the European one, or the German one, to be more specific. There is a USB stick with software that I don't need right now. There's a long USB cable. It's 4.5 meters. And it basically splits at the end into two different plugs. Both of those go into the scanner, and on the other side you have a USB plug and then the power input a little ways along. This allows you to have a huge range of motion with the scanner, letting you move all around the the object you want to scan, and giving you a lot of freedom of movement. That's what I wanted to say. So you just plug both of those in, and then you're basically done. Last, but definitely not least, is a pack of markers. You do need these for some scanning operations if you do want to align your model using markers. There are some specific use cases where that can be beneficial. So, keeping to my own advice, I'm going to put the calibration board back in the box just to keep it safe. And then, you know, these nice carry-on cases, I could put this away now. So you can see here, we have an object that we plastered with markers just so you have an idea of what that can actually look like. For today, we don't need any of that because due to the software not actually playing nice today, I don't have the possibility to scan something live right now. If you do want a closer look at the scanning process with the EinScan H, specifically of a human being, do check out the other videos on our YouTube channel. There is one where we scan. A coworker of mine scanned his arm for a very similar presentation as what we're doing today. So I'm just going to take the power plug, put it over here, since we don't need that anymore. I want to talk about this scanner in a bit more detail, though, because I mentioned that it was a hybrid scanner. Now, what exactly does that mean? You can already see it's handheld, it's quite light, it's about 700 grams in weight, so it's no issue to stand and move this around for half a day. But I want to talk a bit about the scanner itself. And of course now my thing broke that I want to use in order to show it. So I'll just have to click it manually. So this right here is what I wanted to show. And you can see how on the top of the scanner, there's a camera 1 and an infrared light. And on the bottom of the scanner, there's a color camera, a projector, and a camera 2. Now what this means is that the scanner can either use the infrared light or the projector to project light patterns onto the object. Camera 1 and camera 2 will pick up these patterns and then interpolate from the structure they're seeing what the surface of your part actually looks like and what the distance to that part is. The color camera is responsible for picking up, well, the color of the object. It's just there as a texture scanner, so you can have a full color model. That last little lens you see at the top left is just a dummy for future upgrade purposes of the same chassis of the scanner. There's nothing actually behind there. But the real trick here is that combination between a projector for structured light scanning, as in photogrammetry everywhere, and the infrared light at the top, because the infrared light allows you to comfortably scan human beings, skin, hair, eyes, without blinding the poor person that you're scanning, which is often the case if you're trying to go with regular structured light. So for a comfortable scanning experience of a person, this is definitely the better option. You can also see the couple of controls on the back of the scanner. There's a start, pause, and stop button. There's a zoom in or zoom out, and a brightness up and down button. That ring you see around these buttons, that is actually an LED ring, allowing you to get some colored feedback on the distance to your model. So if you're too close to the model that you're scanning, this LED ring on the back will turn red. If you're too far away, it'll turn blue. If it's just right, it'll just be a nice and comfortable green. This allows you to just on the fly readjust the distance between your scanner and your model without having to worry about it. So yeah, as I said, dummy camera, camera 1, camera 2, infrared up here, and the projector down here for the structured light, along with the camera over the color camera over there. It is important to keep in mind when 3D scanning, both of the cameras have to be able to see your object. So for example, if I tried to scan like this, it would never work. If I tried to scan like this, it would never work because both cameras have to see it. That is why scanners have difficulties looking into, what is the word? I'm missing something, like crevices or cracks or holes, anything like this. Anything that's deep and narrow, where not both cameras can look into at the same time, the scanner will struggle with it. This isn't generally the case when you're scanning a human though, so you could use this beautifully to scan a human being. Why would you want to do that? Well, that's where our actual application of the day comes in. What if, I don't know, I broke my wrist, and now I need to keep my wrist still for a number of weeks? Of course I could get a cast, but the break is not that bad that I actually need a cast. A splint would be fine, but all the splints that the medical office has, they kind of suck. They hurt, they itch, they scratch. They're not well suited to my wrist. So what we can do is actually pick up this scanner and scan my, well, broken wrist, but we could scan the overall structure and the look of my wrist like this, and we would have it from all sides. And this would give us an STL file that we can then use in a CAD software to model a wrist splint. This wrist splint can then be 3D printed. And that's where we get to step 2 of today's presentation. Because the Raise3D printers are perfectly suited to printing polypropylene. Polypropylene is a filament that is supremely suited for medical applications. So polypropylene is already fairly popular in traditional manufacturing, in die casting and stuff like this. But now, we can also 3D print it. Traditionally, polypropylene has been very difficult to 3D print because it is very prone to warping. It's difficult to get a good adhesion to the build plate. It's difficult to have supports for it because there's no real support material that would work well with it, but now there is a better solution. So first up, let's look at some of the advantages, and it's still not working, of polypropylene. First up, it is low weight. It has a very low density compared to other 3D printing filaments. On top of that, it is very recyclable. Polypropylene is actually one of the materials that are easiest to recycle out of all the plastics. It is break resistant. You can do some crazy stuff with it without breaking it. I think I'll be able to show that in a minute. It's semi-flexible. It's very resistant to chemicals, which is always great. I mean, in the current application, we're talking about putting it on a human. It's not that important there, but imagine if you were printing containers for chemicals or liquids, or you, I don't know, wanted to make car parts out of it. Then this chemical resistance would come in very handy. It's visually appealing, it looks quite nice, very smooth. It's able to achieve an extremely high surface quality with a very smooth finish. It is safe in contact with food and skin, and this is one of the very, very big benefits that specifically I want to emphasize here. It is not cytotoxic, so you can wear it on your skin for an extended amount of time without having any side effects whatsoever. There should be no allergic reactions, basically ever. And because the surface can be so nice and smooth, you should have no issues wearing this on your skin for a prolonged amount of time. It is also dishwasher safe and sterilizable, meaning that it's easy to clean, especially, I don't know, if you have to wear that wrist brace for 5 months, it's going to reek at some point, and being able to wash it is actually a huge benefit. The filament itself is not hygroscopic, so the filaments don't have to be dried, which is always nice when talking about 3D printing. And it's immediately ready for use. After print, you can put it on the patient, and voila, you've got the product made. There's no post-processing necessary. It is uniformly colorable. In a minute, when I switch the camera back to myself, you will be able to see behind me a bunch of little cups with all the different colors. It is temperature resistant to a very high temperature, over 100 degrees, so you don't ever need to worry about melting the plastic, pretty much. And as I already mentioned, there is certified biological safety for prolonged skin contact. And now comes another kicker. PPprint have developed a special breakaway support material that is great for printing with polypropylene. So let's come back. Here you can see all these little cups that I mentioned with all the different colors. They can also make more if you request it. Right here, we've got an example of the wrist brace that I already talked about. So this, for example, we then printed after scanning a wrist, and you can just slide the wrist in there, have some Velcro straps over here to fasten it, and that would keep my wrist nice and steady, while still allowing for some freedom of movement of the fingers. And this is a much cleaner and much nicer solution than a store-bought off-the-shelf version. Of course, wrist is just one of the possible applications. You could have this for shoes or feet, I mean. You could have that for an entire knee. We've seen applications for scoliosis braces, so around basically a corset for the entire upper body. And because they're customizable, not only in terms of color, but also in terms of shape, it has been found that patients are actually much more willing to wear these as opposed to the regular store-bought ones. Especially in those cases with scoliosis where it's really an individual problem and you have to customize the shape every single time. This scanning plus 3D printing process is a huge help. Right, I want to talk about break resistance. I'll just take this and I can flex it all the way, even bend it more than 180 degrees, and it'll just go back to the shape it originally was. There's almost no way to physically break these things. But take our shoe here. I can do basically the same thing with the sole. I can just bend it all the way around, and it'll just go back to how it was beforehand. So that's another really nice benefit. It's very, very hard to actually damage these things. Right, I mentioned a support material. So there's the filament itself, and as I mentioned, it comes in a variety of colors that you can see behind me. But now PPprint have come up with something else. They have a specialized breakaway support material that is perfect for printing with polypropylene. It has a very high adhesion to the material itself during printing, and then the clue is to heat it up to 110 degrees, and the support material will have a chewing gum-like consistency. So you can just kind of like peel it off your part. So in this example, so the whole thing comes out of the printer like this. Then I put it in an oven at 110 degrees until it's hot, and then I can just peel it off the boot from the bottom, leaving me with only my part without damaging the underside of my part at all. So they really stick together while printing very, very fast. And then when I want to get rid of it, I just heat it up and peel it off without any damage to my part. This allows for better surface qualities of my printed part, while still allowing for a very easy removal of the part from the support material. Now, Raise3D, the last component in our trifecta of orthesis printing. The PPprint filament has been optimized, and there are printing profiles that you can download via the Open Filament program from the Raise3D website for the Raise3D printers, both the E2 and the Pro2. Now, traditionally in the Pro2, you use a steel bed. So you loosen the screws, and you can take the bed out. held down by magnets. Normally, this is covered with a Build-Tack surface. We've already peeled that Build-Tack surface off, because after you do that, you can then take the PPprint starter kit that you can order from their website or from 3D-Druckerexperte.de. Now, in this starter kit, there are some so-called P-wipes, which are specialized cleaning towels. There is a cutter, there is a P-roller, like an application thingy, a couple of leaflets and a sticker, and some cleaning liquid. And what is that cleaning liquid and the roller and the cleaning towels for? Well, it's for the so-called P-surface. I mentioned earlier how one of the difficulties of printing polypropylene was the high risk of warping and the difficulty of achieving adhesion to the build plate. Now, you could also use Magigoo. They have a version for polypropylene. And you could just smear that onto your build plate and hope that it sticks. But in our experience, that has not quite been enough. Instead, there is the P-surface. This right here is an adhesive film you can use to apply a P-surface to your part. But there's one thing missing in the starter kit, and that's the P-surface, because it's not in there anymore. I already took it out. The P-surface, in our case, has actually been applied to a glass plate. Why? Because for the glass plate, it doesn't need any adhesive. You just slap it on there, use the roller to roll it flat, get any of the air bubbles out, and you're good to go. So we can keep our nice steel bed nice and clean. I could put another Build-Tack surface on there. I could switch these back and forth if I wanted to. But for now, I have that glass plate with a P-surface, and I can put this into my Pro 2. Now, one thing I want to mention that when using these glass plates, I do not recommend still using the screws to fasten the plate inside the printer because of the way that everything can expand and shrink when heated. I actually recommend using these office clamps. I don't know whether you can see it. So it's just standard for like files, but they're great to just slide on the front, and they'll hold your build plate nicely in place without any issues when shrinking due to heat or expanding due to heat. So that's our preferred method of keeping the build plate secure, not just one. I recommend you use two at the front, at least one at the back, and then you are good to go and print. Now, this is a very nice way of actually printing with it, and the beauty of it is that during printing, when the build plate has a temperature of around 55, 60 degrees, the part will stick very, very nicely to this P-surface. And as soon as you're done printing, you heat it up to 100 degrees, and once again, the part just comes right off. There's something about the way that the material sticks to this P-surface that just lets you peel it right off. Now, I mentioned the E2 as well, and the trouble with the E2 is that the E2 doesn't have the possibility, really, of using a glass plate as easily. Because, well, it's a different size, and there's no guides on the left and right-hand side, as opposed to the Pro 2. Instead, it's just this plate, and it's a bit more difficult to fix something to it, such as a glass plate. So instead, in the case of the E2, what we did is we bought a second one of these steel build plates, and in that case, we have no Build-Tack on it, and instead, this is the case where we actually did apply the adhesive film directly to the steel bed and then put the P-surface on top of it. This now allows us to just exchange the two build plates for the E2, whether we want to print with polypropylene or print with a different regular material. So let's slide that right in there. Voila, I'm ready to print with polypropylene. One thing I want to mention for the E2 though is the regular Start G code in the Idea Maker has it print a thin stripe of material at the front. You want to delete this from your Start G code for the polypropylene profiles because obviously the P-surface doesn't cover the entire print bed now. Right, so that's most of what I wanted to talk about. Is there anything else? I don't really think so. I just want to reiterate that the Raise3D printers are perfectly suited to printing with this polypropylene filament due to specialized profiles that are verified by Raise3D themselves and have been released for use with these two printers. So there should be minimum optimization necessary in order to get a very nice print result and have your own little wrist braces, finger splints, anything else that you can think of. Yeah, so I guess that's all I have for you today. Thank you very much for watching. I hope you did enjoy the video. If you are curious about more content surrounding 3D printing, 3D scanning, do subscribe to our channel. We do continuously put out new videos. I'm sorry I couldn't scan with the scanner today. Oh, one last thing I want to mention about that one is the EinScan H just got a software update to version 1.0.5.3, and this version has several algorithm optimizations that allow you to capture even more detail than before when in this infrared scanning mode, when scanning humans. So that's really, really cool. I'll be looking forward to testing that one out. And for now, that's all I got. Thank you very much for watching. See you next time, and have a great day.